Okay, today we're going to do optimization, and for this we have a word problem. It says you are hired to make a open-topped square base rectangular prism out of sheet metal. It must have a volume equal to 100 meters cubed. What is the smallest amount of sheet metal needed and the dimensions of the box? So let's start off with the surface area, because we're trying to find the surface area for the sheet metal to make it minus the top. So the surface area of that would be SA is equal to x squared plus 4xy, because you have the bottom, which is x times x, and then you have y times x, and you have that 4 times for each side. And we know that the volume is equal to 100 meters cubed, and we'd also know that volume is equal to an x squared times y. So in other words, we can figure out that y is equal to a v over x squared, or y is equal to 100 x to the negative 2. And we're going to need that because we're going to plug in y for this, or we're going to substitute y for x in this equation. I mean, you can substitute x for y, but there's only one y and the 2 x's, so it's just easier to do it this way. So we're going to have surface area is equal to x squared plus 4x, and then 100 x to the negative 2. And then we're gonna simplify that a little bit, and we'll get surface area is equal to x squared plus a 400 x to the negative 1, because when you multiply these together you can just subtract, add 1 to that. And then we're gonna have then we're gonna get the surface area prime, and that's gonna be equal to a 2x plus a negative 400 x to the negative 2, I believe. Yeah, which is then going to equal to 2x plus negative 400 over x squared over 1, and then we're going to butterfly that. So then the surface area prime is going to equal to a 2x to the third minus 400 over an x. X squared, sorry. Kind of, covered up the x squared with that. So now that we found the surface area prime, we can just make 2x cubed minus 400 equal to 0, and we don't have to make x squared equal to 0, because we're trying to find like the optimum dimensions for this, so we don't have to worry about this because we don't want undefined numbers and stuff. And simplify this to 2x cubed is equal to 400, and then x is equal to a 5.8485 roughly. And once we found out that x is equal to this, we should do a derivative sine chart, and I'm just going to move back up to here to save some space. So we're going to have x and surface area prime. We'll have x is less than 5.849. I changed that from here just to simplify it a little bit more, make it a little bit easier to write. And then we have 5.849, we'll put a 0 there, and x is greater than 5.849. And then what we're going to do, is we're going to plug in, something less than 5.849 into surface area prime, or this equation down here. And so keep it simple, so just do 1. And it doesn't matter what number it is, it just matters if it's positive or negative, and for this it's a negative. And then we'll do the same thing with this, and you just plug in 10 or 1 million, doesn't really matter. The only thing that matters is if it's positive or negative. And we figured out that there's negative here and positive here, so that means there's a minimum here, which is what we want. We want that. And because we know that y is equal to 100x to the negative 2, we can then just plug in x into this, which is going to be 100 over 8.849 squared, because we move this to the bottom. And because if this is the minimum and we plug in x because x is a minimum, when we get y will also automatically be a minimum, and then therefore y is roughly equal to 2.9924 in meters. You can't forget the meters, you can't forget the units, or else you'd lose a point. So we've done that. So we now have the dimensions, which is 5.849 times, 2.924 times a 5.849, because there's a square on the bottom, so those are dimensions. And now that we found the dimensions, we now just need to need to figure out the surface area, and so we just use this one from back here. Surface area is equal to x, and x is 5.849. We'll just plug in the information from before, plus 5.849, and then y, which is 2.924, and then therefore the surface area, and you just plug this into a calculator, which I already did, going to be equal to 102.599 meters squared. And yeah, that is the surface area, and that's it.